Since the beginning of time, we've looked up at the night sky in wonder. Among the stars and constellations, one point of light shone red, a beacon of mystery, a planet unlike any other. This is Mars, the fourth planet from the Sun, a world of dust, rock, and wind, spinning silently in the cold of space. It's smaller than Earth, but its presence in our imagination is enormous. In this journey, we'll spend 3 hours exploring every corner of the Martian world, its harsh terrain, its fascinating history and human thought, the spacecraft that have visited, and the future missions that dream of turning Mars into a second home. Let's begin. Chapter 1. Mars, the basics. Mars is a terrestrial planet, rocky, dense, and shaped by ancient geological forces. It orbits the Sun at an average distance of 228 million kilometers, or about 142 million miles. That puts it just over 1.5 times farther from the Sun than Earth. Mars is about half the diameter of Earth, 6,779 kilometers across. Gravity on Mars is just 38% of Earth's, so if you weigh 100 kilograms here, you'd weigh just 38 on Mars. Imagine how high you could jump. The Martian day, called a sol, is only slightly longer than an Earth day, 24 hours and 39 minutes. A Martian year, however, is almost twice as long, at 687 Earth days. Its thin atmosphere is made mostly of carbon dioxide, with small traces of nitrogen and argon. There's barely any oxygen. The atmospheric pressure is less than 1% of Earth's, making it nearly a vacuum. And yet, despite its hostility, Mars is Earth's most similar neighbor. Chapter 2. The surface of Mars. Mars is a planet of extremes. Let's start with Olympus Mons. It's the tallest known volcano in the solar system, rising 22 kilometers high. That's nearly 3 times the height of Mount Everest. The base of Olympus Mons is as wide as the entire state of Arizona. Then there's Valles Marineris, a canyon system over 4,000 kilometers long and 7 kilometers deep. It stretches across a fifth of Mars' circumference. If placed on Earth, it would span the entire width of the United States. Mars also has vast plains, ancient riverbeds, impact craters, and sand dunes that move slowly with the wind. The surface is littered with rocks, shaped over millions of years by erosion, frost, and meteor strikes. At the poles lie frozen caps, seasonal layers of water ice and dry ice, or frozen carbon dioxide. These polar caps grow and shrink with the Martian seasons, revealing signs of climate cycles. Chapter 3. The Red Planet. Why is Mars red? The red tint of Mars is due to iron oxide, or rust, covering much of its surface. This fine dust reflects sunlight in a way that makes Mars appear red-orange in the night sky. In fact, the name Mars comes from the Roman god of war, chosen because of the planet's fiery appearance. But Mars isn't red everywhere. In many places, the soil is gray, black, or even golden. But that red dust is easily stirred up by wind, covering everything in a thin, rusty haze. Dust storms are a major part of Martian weather. Some are localized, others grow to engulf the entire planet, dimming the sun for weeks at a time. Chapter 4. The Moons of Mars. Mars has 2 small, irregular moons, Phobos and Deimos. Discovered in 1877, they are believed to be captured asteroids. Phobos orbits Mars extremely close, just 6,000 kilometers from the surface. It's slowly spiraling inward and may eventually crash into Mars or break apart into a ring. Deimos, farther out, orbits more slowly and is less massive. These moons are oddly shaped, resembling potatoes more than spheres. They're riddled with craters and grooves, silent, ancient witnesses to billions of years of cosmic collisions. Chapter 5. Early observations. The Babylonians recorded Mars as early as the 2nd millennium BCE. The Greeks and Romans identified it with their gods of war, Ares and Mars. In the 17th century, telescopes revealed that Mars had polar caps. Dutch astronomer Christian Huygens observed dark surface features, including a region now known as Syrtis Major. By the 19th century, Italian astronomer Giovanni Schiaparelli drew detailed maps of Mars and used the word canali, or channels. But in English, this was mistranslated as canals, sparking wild speculation that Mars was home to intelligent life. Chapter 6. Martian Mania and Science Fiction. In the late 1800s and early 1900s, the idea of Martians captured public imagination. Percival Lowell, an American astronomer, promoted the idea that these canals were massive engineering projects built to carry water from the poles. Writers like H.G. Wells added fuel to the fire. In the War of the Worlds, Martians invade Earth in search of resources. The 1938 radio broadcast of the story famously caused panic among listeners who believed it was real. Mars became a canvas for our hopes and fears, a mirror to our dreams of other worlds. Chapter 7. The Space Race Reaches Mars. The first missions to Mars began in the 1960s. In 1965, NASA's Mariner 4 flew past Mars and sent back 21 grainy images of a cratered, barren landscape. The dream of Martian civilizations was shattered, but a new era of exploration had begun. Mariner 9 in 1971 became the first spacecraft to orbit another planet. It revealed canyons, volcanoes, and ancient riverbeds beneath a global dust storm. The Viking program in the 1970s sent the first landers to Mars. Viking 1 and 2 analyzed soil and searched for signs of life. The results were ambiguous, but fascinating. Chapter 8. Rovers and Robots. In 1997, NASA's Pathfinder mission brought the first rover, Sojourner, to Mars. Then came the twin rovers, Spirit and Opportunity, in 2004. Designed to last 90 days, Opportunity kept going for nearly 15 years. Spirit explored Gusev Crater and found evidence of ancient hot springs. Opportunity explored Meridiani Planum and discovered hematite blueberries, tiny mineral spheres formed in water. In 2012, the Curiosity rover landed in Gale Crater. Its mission, search for signs that Mars once had the conditions to support microbial life. It found ancient riverbeds, clay minerals, and organic molecules. In 2021, Perseverance arrived with a new goal: collect samples to one day return to Earth. It also carried a small helicopter, Ingenuity, the first aircraft to fly on another planet. Chapter 9. Discoveries. Beneath the dust, Mars is dry today, but it wasn't always. Orbital images show signs of ancient lakes, deltas, and even oceans. In 2008, the Phoenix lander confirmed the presence of water ice just beneath the surface. Mars Reconnaissance Orbiter detected recurring slope lineae, dark streaks possibly formed by briny water seeping down crater walls. Methane spikes detected by Curiosity hint at chemical or even biological activity. On Earth, methane is produced by microbes and geothermal processes. Geological analysis shows Mars had a magnetic field early in its history. Without it, the solar wind stripped away the atmosphere, drying the planet over time. Chapter 10. Mars in Our Future. NASA's Artemis program aims to return humans to the Moon. But Mars is the next giant leap. NASA plans to send astronauts to Mars in the 2030s. Private companies are aiming even sooner. SpaceX, led by Elon Musk, envisions building a self-sustaining city on Mars, complete with reusable rockets and life support systems. But challenges abound. Mars has no breathable air, no liquid water on the surface, and exposure to high radiation from space. Temperatures drop to minus 125 degrees Celsius at night. Communication delays can last up to 20 minutes each way. Living on Mars will require habitats, food production, recycling systems, and robust healthcare, all in a place millions of kilometers from home. Chapter 11. Terraforming and Ethics. Can we terraform Mars, transform its environment to be more Earth-like? Ideas include releasing greenhouse gases to warm the atmosphere, using mirrors in orbit to focus sunlight, importing ammonia-rich asteroids, deploying microbial life to alter the soil. These concepts are theoretical and require enormous energy, resources, and time. Ethically, some scientists argue Mars should be preserved in its natural state, especially if life, even microbial, is ever found. Should we colonize a planet before we fully understand it? Chapter 12. Mars in Culture. Mars has inspired thousands of books, movies, and works of art. The Martian, 2015, showed the gritty reality of surviving on Mars. Ray Bradbury's The Martian Chronicles imagined poetic, tragic human colonization. In music, David Bowie sang of life on Mars. Mars is even a recurring theme in video games and comics. Why? Because Mars is close enough to imagine ourselves there, but distant enough to remain a mystery. Chapter 13, Final Reflections. We've sent dozens of missions to Mars. We've mapped its terrain, studied its soil, and flown drones through its thin skies. And yet, so many questions remain. Was there ever life on Mars? Could there be life now, hidden underground? Can humans really live there? Should we? Mars is more than a planet. It's a proving ground for technology, for science, for imagination. In exploring Mars, we learn more about Earth and about ourselves. So as we look up at that red dot in the night sky, let us remember, it's not just a distant rock. It's a mirror, a muse, a mystery, and maybe, just maybe, our future second home.